specific calculations. So this is your titration. So you need to realize the 2 Ka values. Where can you find these? In a table. Identify this. And your logic will be, once you see the formula, there should be 2 Ka values associated with each proton. So there are 2 protons, so 2 Ka values. So here are the experimental conditions. So before you add anything, you just calculate the pH based on the weak acid and the Ka. Okay, so you should have no problem to calculate that. Okay, then once you start to add sodium hydroxide, then before the first endpoint, the calculations will be similar. Okay, so it's going to be buffer region. So this is reducing and that's generating. Okay, so because of buffer region, you need to know the concentration at equilibrium for the acid and its salt, right? So you realize that, then you know you need acid and its salt concentration. So the concentration, how much is left, right? How much is left? So initially, this is your sample, right? Initially, you have this total quantity, MV of the total. Then subtract the sodium hydroxide added. This is acid, right? So this is sodium hydroxide added, 10 mil. So the MV of that, millimoles, 1-to-1 relationship. So the difference between the two is how much is left, okay? Then over the total volume, okay? So this is the acid, how much is left at equilibrium. Then how much is generated? So this is the corresponding salt generated. So it's based on how much sodium hydroxide added, right? It's 1-to-1. So there's a sodium hydroxide added, so MV get that many millimoles. Okay, so this is a concentration. Any questions so far? I go slowly so that you can follow me and copy one line at a time. So once again, do not just concentrate on copying from top to bottom and not following. Okay, so best way is follow me line by line and then write down line by line. Okay, so now you realize you have acid and salts, then you employ the pseudo buffer equation. So you're going to employ Ka1, right? So the first plateau's region, and you are solving for H+, right? So it's salt over acid multiply H+. So this is like products over reactant. So this is at equilibrium though. Remember, this is at equilibrium with the two not necessarily equal. This X is not equal to that X. Okay, this is how much acid is left. So this is your unknown, solving for, and this would be the salt, and that is the acid. The 60 is going to cancel each other because it's in the same mixture. The volume going to cancel. Okay, so solving the H+, and take the minus log, then you get a pH equal to 6.15. Okay? So, any question for this region? Okay, then you just add until you add to 25 mils. Then once you add 25 mils of sodium hydroxide, then you realize that is the first endpoint because of that, the MV here is equal to 2.5 millimoles. So 2.5 millimoles and 2.5 millimoles of sodium hydroxide. So analyte number of millimoles is equal to the same as the titrant. So now all the acids are going to change into the HCO3 minus. Okay, so this is the endpoint. Now keep in mind now, this 2.5 millimole is going to carry over to the second endpoint. Okay, so all that is transformed into that. Okay, a total of 28 mils added, then you will realize 25 mils will need to reach the first endpoint. So that now you are 3 mils beyond the first endpoint. Okay, how do you know that? Again, it's just MV, follow all the number of millimoles. Okay, I double underline the 2.5 millimoles. Okay, so at the first endpoint, you have 2.5 millimoles of that. So that is the initial quantity before you add sodium hydroxide, okay, to generate the second endpoint. So the total 2.5 subtract 3 mils of sodium hydroxide beyond the first endpoint, right? 3 mils, so MV of that, so 15 plus 28. Okay, so that becomes your acid, and here, second endpoint material here after the first endpoint. So 3 mils beyond the first endpoint. So you get this generated, then over that. So this becomes the buffer, acid and salt concentration. Any question on that? Okay, so now you just use similar calculation, but be sure you use Ka2, not Ka1. So Ka2 is equal to the proton, unknown amounts of proton, multiply salt over acid concentration, and you get this pH. So the titration continues. So once you add 50 mils, right, then this indicates the second endpoint. Second endpoint, you get this only. So notice you have absolute quantity of 2.5 millimoles for that, and now also 2.5 right here, okay, and here is also 2.5, okay. So because of 1 to 1 to 1. So with that knowledge, at the second endpoint, the absolute total for CO3 minus 2 is 2.5. To reach that, the volume is double, right? 50 plus 50. So it's 100. So the usual calculation that you learned earlier, so the CO3 minus 2 in water, then you use KB value, right? To get the KB will be from Ka2. Okay, so Ka2 multiply Kb equals to Kw. So that's how you get the Kb, and proceed with the calculation, and end up with a POH. The X is the OH. Okay, so we end up with that, change it to pH. Notice the second endpoint is highly alkaline, 11.32. Okay, beyond the endpoint, let's say you add a total of 53 mils, then it's 3 mils beyond the second endpoint. So let's calculate the excess hydroxide concentration from sodium hydroxide. So MV, okay, over the total volume, then you will calculate the POH from there, POH from it, and the pH is equal to that. So it will be higher than that. Okay, so homework will be that, chapter 15, do that.
Is that 31, 22, 27, 31?
Yeah, 31 A, B, C. Yeah. number 22, number 27, and number 31 taught A, B, C. A, comma, B, comma, and C.